as it always can happen, we can make mistakes. We could predict one way, and in reality, it's the complete opposite, which is like the nightmare of all researchers, right? So let's look at the specific type of errors that could occur when conducting significance tests. In other words, hypotheses tests. So type 1 error, I'm going to look at this diagram because it really does make it easier for a lot of people to grasp rather than just words, but you can read it there too. So a type 1 error occurs, this occurs when you reject the null, but when you shouldn't have rejected it because it's true. That is when a type 1 error occurs. Type 2 error, I'm just going to change the color on this, occurs when you fail to reject. Type 2 error occurs because the alternative is true, but when you fail to reject the null and when you should have. So, rejected the null, but you shouldn't have. Oops, right? You failed to reject the null, but in fact, you should have. Oops, again, both are mistakes. Here's a sports analogy that might help. Fouls are basically illegal actions. So if you perform an illegal action, you know, obviously sports have rules, and if you break the rule, you've committed a foul. So type 1 error would be they're calling a foul when there was none. Unfair penalty. So they think you tripped somebody up, but you didn't. Okay? So wrongfully accused. Type 2 error is missing a real foul. So somebody did foul you, somebody did try to trip you up or whatever, and the refs did not catch it. So letting a rule violation go unpunished. In these type of questions, they're going to ask whether type 1 or type 2 is worse in a specific scenario. So you're going to use your judgment call and you're going to justify your answer as to why you picked one or the other. Sometimes there are very clear-cut differences and you're like, hands down, type 1 is worse or type 2 is worse. And sometimes it's like, oh my God, they're kind of both bad. In this case, I felt like these two were almost as bad, but quickly found out from you all, from my students, that they really, really, really think type 2 errors are the worst when it comes to sports. So that, okay? The most common significance levels, again, are the alpha 0.05. This is a very common one. And then 0.01 or 0.10. So the stricter you want to be, the lower is stricter. This is stricter. This is the middle of the ground. This is less strict. Okay, so that's how it usually goes with that. Okay. Okay, let's look at the type 1 error probability. So the probability of making a type 1 error in a significance test is equal to the significance level. So probability of type 1 error equals alpha. Probably should have written that down. Probability of type 1 error equals alpha, whatever your alpha level is. We can decrease the probability of making a type 1 error. So if you want to decrease the probability of making a type 1 error, you also have to decrease your significance level. But when you do this, there's a trade-off. Trade-offs are life. That goes up. The type 2, probability of the type 2 error goes up. So if you're trying to decrease, let me add that here too. If you're trying to decrease the probability of a type 2 error, of making type 2 error, you need to do the opposite and increase significance level. significance. I have to enunciate the whole thing. In other words, alpha. And let's add that here too. All right, so let's look at this question. A potato chip producer and its main supplier agree that each shipment of potatoes must meet certain quality standards. If the producer determines that more than 8% of the potatoes in the shipment have blemishes, which means dark marks or something like that, the truck will be sent away to get another load of potatoes from the supplier. Otherwise, the entire truckload will be used to make potato chips. To make the decision, a supervisor will inspect a random sample of 500 potatoes from the shipment. The producer will then perform a test at the alpha equals 0.05 significance level of, and here are the hypotheses. P, where P is the true proportion of potatoes with blemishes in a given truckload. And they want you to describe a type 1 error and a type 2 error and then the possible consequences first. So let's look at this. Type 1 error. So let's go back to our little diagram here. Type 1 error, this one. Rejected null, but shouldn't have. Okay. So go back. We're here. We rejected this and finding support for that, but we shouldn't have. So we're finding support for this, that means. We're saying that there's evidence that the true proportion of potatoes with blemishes is more than 0.08. So let's write that down. They rejected the P equals 0.08 when we shouldn't have. This means they found convincing evidence that the true proportion of potatoes with blemishes in this truckload is more than 0.08, when in fact it wasn't. So, rejected this, found evidence for this. Oops, wrong. There is no evidence for this. Or rather, this isn't true. They found evidence for this, but it's not true. So, they would have returned a perfectly good truckload back, which is a waste of time, and supplier usually loses the most money in this case. Type 2 error. Oh, I can't spell. Not good. But we all knew that. Maybe I'll do the Roman or not. Let's not. Okay, type 2 error. Failed to reject. So we failed to reject the null, which is P equals, the proportion equals 0.08, when they should have. So in other words, failed to reject this, which means no evidence for that. That means they believe that the true proportion is about 0.8% of the potatoes blemished. But in fact, this is wrong. So what would they have done? In this case, this means they didn't find convincing evidence that the true proportion of potatoes with blemishes is more than 0.08, when in fact it is. So they would have accepted a bad shipment, quote unquote, and they may cause customer dissatisfaction. In the long run, this will cause money loss too, especially for the producer. So in part B, it says which type of error is more serious in this case. Either one is bad and can lead to loss of money. If strictly thinking of the potato chip company, type 2 error might be worse. Type 1 error ends with loss of time, but not money for the company itself, or not as much money. You could have said not as much money for the company itself. Type 2 error will be probably loss of revenue in the long run. Loss of revenue in long run. Right? Because if your customers are unhappy, they're going to stop buying your product. So that's a big problem. Based on your answer on part B, do you agree with the company's choice of 0.05? Why or why not? So if the goal is to reduce a type 1 error, they should reduce the alpha to 0.01 to lower the probability of the type 1 error. So no, we don't agree. But if the goal is to reduce the type 2 error, then increase the alpha to 0.10. Again, we don't agree. And since, I'm going to add here, since type 2 error seems worse, error, I can't spell, seems worse, increasing alpha would be better. Okay, so you're just justifying your answer there. Here's the check your understanding question. Go ahead and pause the video here, but before you pause, there was some disagreement on this in classes. That's because I didn't really read the question properly and I just made a bad assumption. But when I went back to look back at this question, I noticed that the manager at the fast food restaurant, they already assigned an additional employee. So they're not checking to see if the proportion is less than 0.63 to higher, or they're not checking to see if the proportion is 0.63 to higher. They literally did already hire additional employee or just reassigned a person from a different location. In other words, they increased their manpower at the drive-through. So then they collect the data. This changes all the results, actually, the answers. So be very careful. So basically, it's they put an extra employee, then they collect data, then they found this. They see that it is reduced, then that. And so they're saying, there might be some evidence for this. But then if you look at the p-value later on, they may or may not have, but that's not the point. We're just trying to see what is a type 1 versus a type 2 first. So in other words, this is that the proportion of people who wait longer than 2 minutes is 63%, 0.63. And the alternative is that proportion of people who wait more than 2 minutes is less than 63%. And it's after the fact that this employee was assigned for this particular job. Okay? I'm going to try to zoom out, but you can pause it here and then I'll just scroll again and then you can continue. So this is the rest of that problem. It's a long one. And we can discuss this in class too, because it was a good one where we had some disagreements on it.